Okay, this video is going to take you through the last section of new material for Chapter 3. What we cover here will be on the test, the Chapter 3 test. And what you need to know about this particular new set of materials is going to be in the Quizlet, the Chapter 3 test Quizlet. And so after going through this, you should be able to answer successfully the questions on the Chapter 3 test Quizlet. So the first thing I had students do today is to have them write the steps for going to the convent for a fire drill. So if you were to do something like that, it might look like this. Oops. And so if you notice, it's a series of steps. So walk out the VPC 102 north door, go past the attendant's office, through the double doors, take a left. So you can see it goes on and on. This isn't finished, but imagine, continuing on until we are finished and at the convent. So these steps here are kinds of things that we might do every day as far as telling somebody how to do something. And so maybe you give directions to your house or something like that. Or maybe you tell somebody how they can, or whenever you say you do a recipe for making something in the kitchen, you've got different things that are steps, directions for accomplishing a specific task. And so these things are examples of algorithms. So you're expected to know what an algorithm is. So an algorithm is the sequence of steps. So here's the sequence of steps needed for solving a problem. And so it's something also that you might do in math class for word problems. Maybe your teacher says, I would like you to plan how you're going to solve this particular word problem in the math class. And so you would list the steps. That would be an algorithm. And so when we're writing our code, they're algorithms because we're telling the computer a series of steps it needs to take in order to accomplish a specific task. And so the steps need to be unambiguous. In other words, they need to be clear. So somebody reading those instructions would know exactly what they need to do. They need to be steps that are executable. In other words, somebody needs to, if they followed those steps, then they would accomplish the task that's supposed to be taken care of. And so the problem needs to be solved. And then it's terminating, which means that the steps end at a certain time and the problem is solved. It's finished. So this is an algorithm, and an algorithm is something that's used to help programmers plan their programs before they write their code. And we've done something of this nature where we talked about and practiced writing pseudocode before we actually wrote the Java code. And that was a form of an algorithm. Now, with algorithms, we can actually write an algorithm without having all these wordy steps. We can also represent an algorithm with the use of a flowchart. So in the bottom part of this handout is actually an example of a flowchart. A flowchart is a graphical representation of an algorithm. So whatever you write your steps in English, you can transfer that to a flow chart. Now graphical because of these shapes. All right, so these different shapes make it graphical. These are graphics, and so now this is what we're looking at. In this flow chart, we need to be familiar with a couple things as far as the test is concerned. First, you can see how this is a series of tests, not steps, but steps. So first we want to prompt the user for, let's say, a test score. We want to be able to tell them whether they passed or failed the test. And so we prompt the user for a test score. Well, that's a print statement, and that's output. And then you have the next line. So you see the arrow here, go here. Now we're going to read and store the user's score. Well, that's going to be the code that reads and stores user input. And so this is, let's get this out of here. So what these are, these two shapes, they are parallelograms. So parallel, whoops, are used to for input and output. So when a programmer uses a flowchart, a certain shape is used for specific types of actions. And so when we're dealing with input and output, the programmer uses parallelograms. So now you notice then that it goes from prompting the user for a test score, the user responding to that and entering a test score, and then it takes us to a diamond. All right, so a diamond is another shape that's used in the flowchart. And so a diamond is used for decisions. And so that's what we've been doing in Chapter 3, is programming the computer to make a decision based on something being true or false. And so as we see here, we have scores greater than 59. Well, that is, we already know, is a Boolean expression or a condition. The compiler evaluates it to be true or false. And so that is, a decision is made, because if it's true, it goes one way. If it's false, it goes the other way. And so what the compiler does, is if it's true, in this case, then what it's going to do is going to go left as we're looking at it. So if it's true, we go left and we execute what's inside of this rectangle. So what rectangles? Well, what are rectangles used for? Those are used for processing tasks. All right, they're used for processing tasks. This task here, if the score is greater than 59, then what we do is we store pass in the test grade variable. All right, and so now if it's false, then the other decision, or the other option it could have, is to go to the right, and it has another rectangle, which is processing the task of storing fail in the test grade variable. So rectangles are used for processing tasks, diamonds for decisions, parallelograms for input and output. And so again, this is a flow chart, which is a graphical representation of an algorithm, or a graphical representation of a sequence of steps that are needed to solve a problem. All right, so what you need to know about algorithms and flowcharts is in the Chapter 3 test Quizlet.